Hello viewers, today we will discuss about the address calculation of one-dimensional and multi-dimensional array. Let's start with one-dimensional array. In one-dimensional array, we do not face column measure or row measure addressing, but in multi-dimensional array, we will solve how to calculate row measure and column measure address. Let's start with one-dimensional array. If a one-dimensional array is given such that lower bound 20, upper bound 70, and base is 500, and 6 word per memory cell for A, then find address of A65, A69. Okay, let's start. We know location of array index k is base of A plus word per memory cell W, word k minus lower bound. Here LB lower bound is 20 and W is 6. Okay, let's calculate. Base is given 500. So look one number, look or location for 165 equal to base of array double A word per cell. Here k means 65 and lower bound is 20, and putting this value 500 plus word 6 and 65 minus 20. After calculation, our answer will be 770. 700. Again, for location array of 69, base of array plus word per cell 69 minus lower bound 20. Okay, 500 plus 6, 69 minus 20. After calculation, we will get 794. Let's calculate n-dimensional array's location. We know there are two types of location, row measure and column measure. At first, we write down the length, effective length. Effective lengths L1, L2, L3, L4, Ln, and effective index E1, E2, E3, E4 En. Now here there is a short technique. we do not remember to how the formula begins, but there is a short technique. We will multiply E1 into L2 and then add E2, then imply with L3 and then add E3, imply with L4, then add E4. Okay, here I have to write here L equal to upper bound minus lower bound plus 1 and effective index E is equal to K minus LB. Okay, so location, so the location for n-dimensional row measure K1, K2 dot Km to base of A plus word per memory cell W, and then our tricks begin. Here we have to write E1 L2 multiply E1 L2 plus E2, then again multiply with L3 plus E3, then again multiply L4 dot 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 En minus 1 will be multiplied by Ln plus En. Okay. Here we made certain mistake that we kept m, but if we make it n, then our equation will be easier as we have assigned n. So let's try to locate location for n-dimensional column measure. Location for n location for n-dimensional column measure. Location of K1, K2 dot 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 Kn equal to base of A, word per memory cell W, and here our short technique begins. We have taken for row measure there E1 multiplied by L2, then added E2, and then multiplied E3 and added E3, but here we have to multiply from another side, from n multiply En into L n minus 1 and then just add E n minus 1, then again begin the same, and at last what will we get? Just dot add, then multiply. Okay, then we will write E n L n minus 1 plus E n minus 1 L n minus 2 dot E okay, and after the ending plus 1. Okay, here is our equation. Easy process, just En into Ln minus 1, then add En minus 1, then multiply just back and till the end. Just last checking that everything is okay. E2 L1 oh sorry, here I mistakenly, this will L1 this will L1 and then okay. We will clear with an example next. Here we can see a 5-dimensional array is given, which lower bound or upper bound of 5 dimension are given, and we have to calculate the location for A3 minus 1 8 4 2 in row measure and column measure order, where base is 400 and word is 4 per location. Let's solve. Let's calculate the lengths. Lengths L1 is equal to upper bound minus lower bound. Upper bound, here you can see 8 minus lower bound is 2 plus 1 plus 1, so comes 7. If we do the same process, lower bound upper bound minus plus 4 plus 1 is equal to 6, lower bound 3 goes to 10 minus 6 plus 1 is equal to 5, L4 7 minus 3 plus 1 equal to 5, L5 equal to 6 minus 2 plus 1, so 9. Okay, we have calculated the length, and now effective index or indices, you can say anyone. E1 is equal to k minus lower bound. So here you can see 3, here is k is 3, so 3 minus lower bound is 2, so our effective index will be 1. E1, E2 minus 1 minus lower bound minus 1 minus lower bound minus 4 is equal to 4 begins 3. E3 here 8 minus lower bound 3, so lower bound 6 here, mistaken, to E4 4 minus 1 2 3 4 here 3, so our effective index will be 3, sorry 1. For index 5, 2 minus lower bound 2 minus 2 plus. Okay, now for row so for row measure order, location for A 3 minus 1 8 4 comma 2 equal to base of A plus W. Now we have to calculate the same process, L1 L2 L3 L4 L5 E1 E2 E3 E4 E5, start multiply dot plus multiply plus multiply plus multiply plus. Okay, E1 L2 plus E2 L3 plus E3 multiplied by L4 plus E4 L5 plus E5. Okay, now here our shortcut technique, E1 L2 plus E2, then multiplied L3 plus E3 and so on. Now putting the values, base of A is given 400 here, so 400 plus W is 4 here, so putting the values, E1 L2, E1 value is 1 and L2 is 6, 1 into 6 plus E2, E2 is 3, L3 is 5 plus E3 is equal to 2, okay, L4 here is 5 plus E4 here is 1, L5 here is 9 plus E5, here is 4. Now if we calculate, then you will get 8, 9, 1, 2. This is our row measure location for A3, minus 1, 8, 4, 2. Now we calculate for column measure order. For column measure order, location for A3 minus 1, 8, 4, 2 equal to base of A plus word per memory cell W. Now here we have to apply L1, L2, L3, L4, L5, E1, E2, E3, E4, E5. Multiply here, then add, multiply, add, multiply, add, multiply, add. Okay, let's begin. E5, L4, multiply, then add, E4, then multiply, L3, plus then add E3, then multiply L2, plus add E2, multiply L1, then add just E1. Now let's put the values. Here we had base 400 plus word per memory cell W was 4 E5 L4 E5 4 into L4, here is 5, plus E4 1 with L3 5, plus E3 2 with L2, here 6, plus E2 3, L1 here is 7, plus E1 here is 1. Okay, now if we calculate, we will get 1, 8, 4, 6, 4. Now you have observed that with this process shortcut we can easily calculate n-dimensional arrays location of its in any index. There will be no problem to calculate. If this video helped you, you may like and subscribe. Thank you.